Okay, here we go. This is, what is this, 5.1, day number 2. By the end of the hour, you'll be able to determine average rates of change. Guess what the average rate of change, the function or the formula for it is? Slope. That's all. All right, average rate of change is just slope. Okay, we're going to talk a little bit about parallel slopes and perpendicular slopes and then do some maths. Oh, yeah. Game Boy. Color. Don't get confused. Okay, so the cost in dollars to produce a certain number, X, of portable game systems, right? We can't call it Game Boy because copyright issues, even though it says it right there. Okay, well, this is recorded, going on YouTube, so find me if you want to. Won't even affect my paycheck, or at least I won't notice it. Okay, what would C of 10 mean? What would it mean? Joe? But what does it mean? Yes, plug 10 in for X. I can do that. If you produced 10 Portaboys, it would cost us $950. All right, so the cost to produce 10 Portaboys would be $950. Okay, sweet. How many Portaboys can be produced for 15,000? Well, in this case, now I'm going to take that 15,000. That's going to be my output. Plus 150. And I'm going to solve for that. I don't really want to even think about doing that mentally. Subtract 150. That'd be 14,850. Somebody, I heard the calculator start creeping out. Okay, so let's say 180. Well, we need to meet that number, so I'm going to round that 185 point whatever to 186 Portaboy systems. Why not?
You would round down because you can't make Portaboy.
Yeah, but I have to make 15,000. So I'd have to round up to hit 15,000, right? If I went down to 185. Huh? Correct.
So you can't spend like half the money on a Portaboy.
Okay, but I can't make 185.6 Portaboys.
Make 180.
Well, then I don't make 15,000. That doesn't cost me 15,000 bucks. Then it only costs me 14,000 whatever. Okay, you see where I'm at? There's an interpretation here. Okay, for those of you on the World Wide Web, we're going to pause and argue about this because Maureen wants to. Wide Web. Okay, children, Maureen is happy that she won this argument, that I only have $15,000 to spend on Portaboy systems, so I'd have to round down to 185 units. Okay, because otherwise I go over my budget of 15 grand, which to me is basically like a couple days worth of work, whatever. I don't even care. All right. Now, explain the significance of the restriction on the domain. Why does X have to be greater than or equal to 0? We can't make negative Portaboys unless we turn them inside out like the weird stuff from last unit, right? The reciprocal functions where the lady's face was on upside down. Yeah, really weird. Okay, so, of course, the number of Portaboys is going to be either 0 or more, not negative. How would we interpret C of 0? Because C of 0 does exist. C of 0 is 150. What? The company that is producing these for me says, oh, you signed the contract? Give me 150 bucks. Oh, now we'll start charging you $80 per unit you want produced. Oh, thank you very much. I'll take that 150. That'll be a processing fee maybe, right? I'm going to process you in as a customer. Oh, that's great. So if on the test I ask you to interpret that and you say C of 0 equals 150, and then you don't interpret, like, say, what it could possibly mean, well, you get it wrong because, yeah, C of 0 is 150, but it says interpret. All right, find and interpret the slope of the graph, C of X. Well, the slope is 80. What does 80 mean? I just actually said it a couple minutes ago. Slope is 80. What does it represent? All right, because here's our graph. Say again. Yeah, cost per Portaboy. It's 150 bucks right to start. Thank you very much. And then 80 is the slope. Well, that's $80 per Portaboy produced. Is that the answer right there? I just want to see who's paying attention. So $80 per porta boy produced. Now, things aren't always linear like this. Example here. Now, let's say that this local retailer determined that X porta boy game system sold in a week is related to the price, meaning the more that's sold, the less they'll sell them for. Right? Then it's no longer linear; it's quadratic in nature. All right, so when the price was $220, 20 games were sold. When the systems went on sale, then they were sold at a lower, or a larger number of them would be sold. Well, that makes sense, right? As a consumer, if the price is higher, less people will buy, but if the price is lower, more people will buy. So let's find a linear function that fits this. So can we do that? Is it possible? I mean, technically, I could find like this function that would predict. It might not always be accurate, right? Because we can't predict what humans are going to do. We're going to lower this to $8. People will be like, $8? I'm not buying it. It's probably crappy, right? Even though you think, oh, if I lower it to $8, tons of people will buy it. So we can predict using this idea of a linear function, assuming that we can say people will act this way. They'll behave this way. So find a linear function that fits this model. Well, in order to come up with a linear function, I'm going to have to come up with a couple points, right? I need a slope. So 20 games were sold, or game systems were sold when the price was $220. And 40 were sold when the price was $190. So I could find the slope between these 2 points. Is the price going down or up? Down. So my slope, in this case, I could take 190, which is my y value, minus 220, which is my other y value, over 40 minus 20, and I get negative 30 over 20, which gives me a slope of negative 3/2. Okay, so the price is related to the number of units in this way. Okay, this is going to be point slope form. Okay, I need a point and a slope. Well, I know a point. I could use either of these two. In this case, I'm going to use 190. The slope is negative 3/2, and the x value that goes along with that is 40. This right here could help us to predict either price or number of units based on the other one. So let's find a suitable applied domain. Does it make sense for us to produce less than 0? No. Okay, so the domain here would be 0 to infinity. Maybe infinity is going a little too far with that, but we can assume, right? And the domain here is which variable, x or p? X, right? Number of units sold, right? So the price will change based on that. Interpret the slope. What does this thing mean? What does this negative 1.5 mean? Right, I got it right here. Negative 1.5. What does that mean? Well, let's look at a sketch here real quick. Let me sketch this. Here's just a little baby sketch. Actually, I'll make it bigger down here. Okay, I went from 20 units sold at $220 to $190 per 40 units sold. So the slope of this, very poor color choices here, I have to say. Okay, what does the slope mean? Well, it's the change in y, so it's the change in what? Price per change in units, number of units. So it's negative $1.5 per unit, or in this case, system sold. So the more you sell, for every one game system you sold, the price will go down $1.50. Okay, again, we can't put specific behaviors on humans because we don't know. We're not 100% certain, but we can predict. Okay, if the retailer wants to sell 150 Portaboys next week, what should the price be? I'm not going to go through this, but where would we plug this 150? Plug it in for X, right? Solve for P. That would give us the price. And in the next one, what would the weekly sales be if the price were set at 150 per system? Well, I plug 150 in for P, and then I solve for X. So either way, you can predict what we would get there. Keep going. All right, so here is our slope. Right? Here's our slope, which is, as we're talking about, the average rate of change. We just talked about how this situation is not something we can predict, right? We said humans are not predictable. However, we can take 2 points and predict based on the line that connects them. So in this case, I can find the average rate of change from, let's call it A to, let's call it B, right? This is the beginnings. This is like baby calculus. You can call this baby calculus. Baby calculus. Okay, because this is, remember this from the previous unit? F of x plus h minus f of x over h. That's all that is, right? I've just added h to a. So b is equal to a plus h. Okay? All we're doing is finding slope. So in an example like this, if I want to find the average slope, that should be the average rate of change. Okay? What would I do? What should I do? On this interval, that should be an interval. Interval from 1 to 2. Well, let's find f of 1 and f of 2. Subtract them and divide them by the change in the horizontal, right, from 1 to 2. Okay, so f of 2, well, that's 2 to the 4th, which is 16. 16 times 3 is 48. 48 plus 2 is 50. So f of 2 is 50. F of 1 is 5. Whoops, that should be a minus. Over 2 minus 1, which would be... So the average rate of change, or the slope between those 2 points, or those 2 endpoints of that interval, should be 45. So the slope between those two would be 45. This is just a different way of saying find the slope between, what would that be? 2 comma 50 and 1 comma 5. Find the slope. Well, the slope's going to be 45. Done. All right, young people out there. If 2 lines have the same slope, then they are what? Parallel. Oh, too easy. Okay, so then I know the slope of a line parallel to this line would be 2/3. -3, -1, 0, and 0.75. I'm going to write that as 3/4 for a very specific reason. Does anybody know how 2 lines that are perpendicular, their slopes compare? Joey? Opposite and reciprocal. So opposite would mean 2/3 has to be negative, and reciprocal 3/2. Wow, that was probably one of the worst 3s I've ever drawn in my life. Okay? What would be the opposite reciprocal of -3? How about -1? Good. How about 0? No. Undefined. And our last one. -4/3. Oh, thank you so much, Mr. Ludd, for writing that as a fraction, because now when I do the reciprocal, I'm not scared. That was $8,000 worth? All right, kids at home, I just made $8,000. Maureen said it. Okay? And that is average rate of change as well as slope, as they say in France. Peace out.